Hello, and welcome to this edition of the Fair Data Podcast, where we discuss all things fair, making data findable, accessible, interoperable, and reusable. I'm Rory McNeil, host of the Fair Data Podcast, and my guest today is Nick Garabedian, group leader of linked tribological data at the Karlsruhe Institute of Technology. Nick, welcome. It's great to have you on the podcast.
Thank you for having me, Rory. It's my pleasure to be here as well.
Great. So we'll get into fair data as we progress in the conversation, but first let's start with some background. Your area of research is tribology. I suspect that's a field that's not familiar to many of our listeners. Could you give us a high-level overview of what it's about?
Sure, tribologists deal with scientific and engineering questions related to friction, wear, and lubrication. Tribology is a relatively young field of its own and came into existence after the British and then the US governments realized how much energy was wasted due to not too well understood contacts between moving parts. The potential savings to the world economy in case better technologies are applied are estimated to be around 1.5% of the world GDP, which also corresponds to 9% of the global energy use. So, it is a trillion-dollar question of how to bring better technologies into widespread practice, and that's valid for both the economy and the fight against climate change. If there's one thing that I would want people to understand about tribology, it is that it is really all around us. Anytime you have a system of more than one part, you start to have tribological issues. Obviously, you can think about cars, and probably most people would associate that with tires and engines. However, to give you a less obvious example, imagine buying a new car. I see many car journalists compare how plasticky dashboards are, for example. Well, the feeling of whether something is plasticky is all about the surface pattern of the plastic, its material properties, and the tactile feeling that we have. Well, that's the job some tribologists actually do.
I see. So it sounds like virtually any context, any environment one could imagine could involve moving parts. And you just gave the example of skin and cars, but I guess there's probably hundreds or even thousands of others. It's very ubiquitous almost. Is that right?
Yeah, absolutely. I mean, one of my first projects during my PhD was to deal with issues related to space lubrication because, you cannot just go and spray oil on some exposed part. Other applications include earthquakes or the joints in the human body, so there are also many problems that tribologists deal with beyond the classic metal and metal contact.
Right. And I guess one of the things would it be true that one of the things you explore is commonalities or commonalities across different environments, but it's still basically a moving parts issue. Is that right?
Yeah, exactly. Every time you have more than one part in motion against each other, you have tribology.
Right. Okay, great. Thanks. That's very helpful. Also helpful to me. To provide a bit of additional context, you're currently leading a group at the Karlsruhe Institute of Technology. So what appealed to you about KIT as a home for your work in tribology? Is there other work going on at KIT that's complementary to your research? And how have you found it as an environment for conducting what's obviously a very innovative field of research?
Well, KIT has a long history of materials research. A few years ago, a special institute was founded there called the Microtribology Center. If I can put boundaries on it, micro and nanotribology are my specialty, and finding an entire center with multiple buildings dedicated to that was inspiring to me. It is a joint venture of the KIT and another organization called Fraunhofer IWM, who deal with applied material science and industrially relevant research. I think it's also important to say that it's not always all about work, but really, I actually like the geographical region and the local culture and lifestyle. Now, the idea of working in fair data did not occur to me before I showed up in Karlsruhe. Instead, I would say the environment here fostered it. I think everyone is aware of the potential of data, but really nobody still has the 100% correct answer to it. I would actually start sleeping well when we reach 70% of the answer. But anyway, at the KIT, I've been surrounded by people who realize the magnitude and the importance of fair data. And there are a lot of specific activities related to modeling and simulation, and a few electronic lab related efforts as well, which just all came together.
Yeah, interesting. I myself have had only very limited contact with the KIT, but I recently came across a group that's working on PIDs, permanent identifiers for equipment, developing a standard for that. So there's another example, I guess, of the kind of relevant work to fair data that's going on at AKIT. But anyway, it's great that it's such a stimulating environment. So I was intrigued. You're saying you really got into fair data after you arrived at KIT. So I do understand that that fair data is now central to your research. So can you tell us a bit about how your fair journey began?
Sure, I think we were working on fair data before we knew about fair data. I think it's relevant to say that for a while I've been thinking about whether we can have a universal tribology law. Say, can we design tribological systems bottom up instead of observationally? Reading more about machine learning, I realized there was some potential there for designing such a system that could predict the friction between bodies, which we currently cannot do. But for that to happen, we would need a lot of data. So my first idea was to make a relational database for the data that the lab produces. But then the column names started giving us trouble. Because tribologists all come from different fields, be it mechanical engineering, chemistry, or physics, we don't have a standard way of calling things. And right around that realization, the COVID related restrictions were starting. I had a colleague who had the idea of making a local instance of the wiki software where we could collect a glossary about the objects and processes in the lab, and all of that could be done online, which was something to do while our labs were with restricted access due to the COVID regulations. So, this wiki with this wiki, we were essentially working on metadata, and voila, that is what fair data is about.
Great. And so that's probably a good lead in. And how did ontologies come into the picture? And what kinds of, I know you're working with ontologies, so what kind of ontologies have you been incorporating into the research?
Well, the wiki that I just described had a part that was actually annoying me. We collected many terms and definitions there, but there were repeated labels. For example, every process has certain characteristics that are shared, like the fact that there is somebody performing a process or that there are specimens involved. Each process we specified in the wiki had its own basically copy-paste such label. And although the wiki software has semantic plugins, I started thinking that really the general solution is to maintain an ontology. I convinced myself that ontologies can be a bridge between connecting vocabularies, electronic lab notebooks, and machine learning models. So I started looking for an ontology that would be helpful in this quest. But then I quickly came to the realization that there was nothing close enough to our objectives that we would be just use out of the box. Around the same time, an ontology for tribological knowledge was published by another group, and I thought that could be the one for us. However, then again, I realized that to connect the glossary to the electronic lab notebook, we don't need an ontology of tribology per se, but actually an ontology of tribological experiments. And that's how our ontology was born. Of course, I used the general ontology of tribology as much as I could so that in the future, when we want to start encoding really rich knowledge, we could use that ontology as a foundation. So, just in general, I would say that the ontology we're using is based on the Sumo, Expo, and Tribane ontologies in order of, I guess, upper to lower. With all of this knowledge, I went back to our specific project and we decided that the best test for our metadata would be to have a showcase, a relatively standard experiment in the lab that could use the vocabulary, the ontology, and electronic lab notebook, and then a public repository. We wrapped all this together and published it as a blueprint for our community to start discussing the strengths and weaknesses of the fair data approaches that we developed.
Okay, that's really interesting. So, um, so that's kind of how following how the ontology work um, got started, and also how it kind of changed shape a little bit as you got into more of the understanding what was really going on. And then, if I understand it correctly, then that developed into an actual formal project that's been funded by the Helmholtz Metadata Collaboration, to kind of maybe scale up or take it to a more higher level, and you're developing user-friendly tools for fair controlled vocabularies composition, so the actual tools to produce the vocabularies, and then there's subsequent conversion into ontology. So that sounds really interesting. So what are some of the challenges involved in moving to, if I understood it correctly, kind of scalable production of controlled vocabularies?
Yeah, exactly. So with the paper that I just described as the general framework finished, we were looking to make what we do easy to repeat and incorporate into other labs. The challenge with ontologies is that it takes deep domain expertise and also good understanding of logic, semantics, lexicology, and a bit of programming. So it was extremely time consuming for me to re educate myself to be able to translate our natural knowledge about tribology into essentially computer language. So I realized that just composing vocabularies for each lab is a non intimidating way for newcomers to the fair data world to start their journey. However, what I was looking for actually didn't exist. We had a few criteria. What we developed had to be collaborative with voting, discussion, and validation mechanisms. Additionally, the schema running in the background of the whole thing had to automatically bring this vocabulary into a form ready to be converted into a rich ontology. So, to your question specifically, what's hard is to make things easy to use. The solution we have made and just started testing is called Voc Populi, and it lets you construct trees of terms and definitions, and also lets you define whether we're talking about data, and if so, what are the expected formats, or it lets you put in relationships like the fact that a type of a machine uses a type of a specimen, and what's happening in the background of this whole thing with Voc Populi is that there is a SCOS and a PROV ontologies being assembled and tracked by a versioning system. We use a Git server to manage the versions and record all the provenance.
Well, that's really interesting. I want to come back to that in a moment, but also just since we're on the topic, since we're speaking about the Helmholtz Metadata Collaboration, I just wanted to put in a plug for the conference that they're running, which is taking place on October 5th and 6th, and I'm planning to attend myself. I'm looking forward to it. But I guess you'll be involved in the conference. Can you tell us a little bit more about the conference itself, and if you are going to be involved, how, what you're going to be doing?
Sure. So our involvement so far has been to write an abstract for a poster that we will present. But really, the HMC is a great organization, not only because they chose to sponsor us, but because they're looking for general metadata solutions in a democratic way. In fact, our work on Voc Populi is a collaboration with three more labs in a Helmholtz center in the north of Germany called Herion. And we only discovered that collaboration because it was one of HMC's requirements to involve multiple research centers and to use that as an important way to verify the applicability of our Voc Populi. But in any case, the HMC also organizes regular events that are meant to bring exchange first between their own projects, for example ours and other projects from the consortium, but they're also trying to bring in the outside world so that what we develop within the HMC and the Helmholtz Association works for other entities as well, from around the world. Or, that's my own opinion. At least that's the impression I got from all my communication with them, and I hope I'm representing the facts correctly.
Excellent, fantastic. So let's with that little parenthetical discussion of the HMC, let's come back to what you were saying earlier, which is so interesting about the production of ontologies in a systematic and scalable way. And as I understand it, and as you've already kind of alluded to, but you don't think of controlled vocabularies as operating in a vacuum, and you're actually exploring ways in which they can be applied to and used in particular, I think, in ELNs. So this seems to me to be a really important problem. It's a lot of the discussion in my experience, a lot of the discussion about things like PIDs and controlled vocabularies seems to assume that these things just exist. But when you actually go to try to use them and make them usable in the context of tools that people use in research, that presents a whole additional series of challenges, which I think oftentimes those challenges are overlooked or ignored or not even thought about by people who are doing work in PIDs and controlled vocabulary. So you're trying to bridge that gap, which I think is fundamentally important. So could you tell us a bit about that aspect of what you're doing?
Yeah, absolutely. And actually, that's what I'm most excited about. Because I think we're actually working at the interface between all these different aspects, and how should they coordinate their actions together, like the PIDs, the ELNs, and the ontologies. So, thinking about in that direction, at some point I realized that one doesn't need an ontology to start collecting fair data. For any fair data to be called such, it is required to have fair vocabularies. Currently, I'm not sure how that could be done. I've looked at many published fair datasets, but could not really find out how and why they arrived at the names of their table columns or the keys their ELN uses. I believe that what we're building with Voc Populi is a solution for fair vocabularies, which will speed up the connection between ELNs, scientists who have completely bought into the fair stuff, and machine learning. So I'll try to describe the most straightforward case I can think of. Technically speaking, a few lab scientists can each go on the Voc Populi and propose terms, comment on them, and vote on them. Then an administrator or somebody who is appointed for their expertise in the specific domain can go in and change the status of the terms. That triggers multiple actions on the PID side of things, and the way the data is organized, and the branching on Git. Importantly, all of that is done automatically, and the domain experts don't need to worry about it. Next, once we have a set of agreed terms on Voc Populi, we offer a converter to JSON or an integration with an electronic lab notebook where templates can be assembled directly from the vocabulary that came from the domain experts. The idea is then that the electronic lab notebook records made with these templates will carry the ID of the vocabulary which they used. Eventually, any metadata in the ELN record can be traced to the exact discussion that led to something being called the way it is. Of course, every simple story has a complex background, and in our case, there are a bunch of technical details that we had to fight in order to make a reliable system that behaves the way that I described. And of course, we are developing a module to convert the vocabularies to ontologies, again, without the need for deep understanding of ontologies, but that is still in its early stages of coding.
Well, fantastic. Well, to me, this sounds like this is very closely related to some of the work that I've been involved in, and it sounds to me like that you've reached the Holy Grail, or you're reaching out for the Holy Grail. So this is really fantastic. I'm, first of all, thank you for doing this critically important work, and I'm definitely going to look forward to following it as it develops. This is wonderful. Um, so I mean, so kind of coming on to your point, because it's interesting. You've been in your conversation. You've been a number of times you've mentioned the phrase "making it easy for people," and so people don't have to do extra bits of work. People that don't understand, that aren't particularly computer literate, can still make use of it. This kind of theme has been, trying to help things, because I think a lot of as ontologies are a good example of something which is it's a nice idea, but for most people it's either too much work or too complex to learn, and it just it's and you're trying to democratize the use of ontologies and streamline it. So I think so. So this makes me think one of the great divides in biology and related fields generally is between the long tail of wet lab researchers who don't have computational knowledge and oftentimes are not particularly interested in it, on the one hand, and on the other hand, the rapidly growing cohort of computationalists. So do you see the work that you're doing as helping to bridge that fundamental gap, and if so, how?
Yeah, absolutely. You're touching upon exactly the problem the way I see it. I think most technological solutions are actually out there, but it's really about adoption and making these solutions applicable to the specific problems people face in their daily work. I think I, for example, had to re-educate myself and spent a lot of time studying new directions in the fair data field before I could really say that the solution we suggest is one of the ways to fairize tribology. Well, now talking about biology, well, I actually don't know much about the field, but I had to learn a little bit while hunting for ontologies. And what I discovered is that I think the problem can actually be compared, the problems in biology can be compared to the problems in tribology and material science. I think what computationalists and experimentalists aim is actually the same thing, understanding the world. But the way we set our experiments up are very different. Therefore, I think it's important to identify the commonalities and the differences and then encode them into our work. I believe the computational and the physical worlds can be reconciled on a large scale via machine learning, but for that, one needs to teach the computer the true meaning and relationships between the worlds. In fact, I would say it's not this case of between computationalists and experimentalists. It's not too different than a case in a purely experimental setting, given that different labs often obtain different results and need to find a way in which they can examine the things that they're doing differently, and that relates to the fight for better reproducibility and so on. So, to conclude, as long as people have vocabularies assembled by the same guiding principles, uh, not not the same vocabularies necessarily, but assembled by the same principles, I think we should be getting close enough to automatically linking any newly produced results. And after all, I think that's what FAIR is all about.
All right, fantastic. Well, that's a perfect note for us to end on. So Nick, thank you so much for this inspiring conversation.
Oh, thank you so much, Rory, for inviting me. It was so great chatting with you and exploring all of these topics.
Okay, great. Okay, so that's it for this episode. I hope you enjoyed the discussion. The Fair Data Podcast is provided by fairdatapodcast.org and produced by Meroz Ahmed. You can find us on Spotify, Apple Podcasts, and Google Podcasts, and follow us on Twitter at Fair Data Podcast. New episodes are released every Wednesday at 8 a.m. Pacific, 11 a.m. Eastern, 4 p.m. UK, 5 p.m. Central European Time, and late in Asia Pacific and elsewhere. See you then.